Okay, so hello and welcome. Here we are, another question. This is going to be greatest sum divisible by 3 on LeetCode. Just take a moment to make sure everything's working. Got the audio. Greatest sum divisible by 3 on LeetCode. Just take. That's working, and the chat is fine too. Let's go ahead and set up for the next question. I think everything's fine. Yes, okay. So, find elements, no, greatest sum divisible by 3. Let's go for that. Oh, didn't mean to do that. Okay. Given an integer array nums, return the maximum possible sum of elements of the array such that it is divisible by 3. Integer array nums, return the maximum possible sum of elements of the array such that it is divisible by 3. Oh, that's interesting. It's a subset of the elements? So pick the numbers 3, 6, 1, and 8. Their sum is 18. Maximum divisible by 3. Oh, okay, that's interesting. How many numbers are there? 4 times 10 to the 4th. Relatively low submissions, pretty high acceptance. This is like a reasonable question. Numbers are between 1 and 10,000, and there's about 40,000 numbers. Okay, so everything that's divisible by 3 you take immediately. Things that are divisible by 1 and 2, you could pair them off. And then things that are... could also pair things that are divisible by 2 into pairs of 3, right? So which numbers do you not include? I think the way to do this, I think I could do this in linear time using a heap. Yeah. And I'll explain what I mean by linear time and using a heap. So if you take the sum and check if it's divisible by 3, take it modulo 3, it's either 0, 1, or 2, right? There are only 3 options. If it's modulo, if it's 0, then you're done. Can't get a larger, these are all positive numbers. You can't get a larger sum than just adding them all together. If it's a 1, then you've got to either take the smallest number that's modulo 1, or take the 2 smallest number, remove that number, or take the 2 smallest numbers that are modulo 2. And you can't get mod 1 without either of those options, and remove those from the sum. Both of those can be basically figured out and put into a heap. Well, I mean, you could just find those directly, actually. Yeah. That's if you're at mod 1. If you're at mod 2, then it's either the smallest number that's mod 2, or it's going to be 2 of the smallest numbers that are mod 1. So basically find the 2 smallest numbers that are mod 2, smallest numbers that are mod 1, and calculate the total sum. Yeah. Okay. So let's do that. And that should work fine. Just calculate the total as we go. Or modify the total. We'll do int mod 1 size 2, and then mod 2 size 2. These will just be 0. And then we say, let's do 10,000 actually. Sentinel values. Okay. So for each value x, if x is less than mod 1 0, or let's say it's less than 1, then mod 1 1 equals x, and sort mod 1 plus 2. Right? Same thing here. This is less than mod 2. Something like this. If it's less than the largest of the two, then we're gonna replace it in sort. Yeah, that'll give me the two smallest. That's one way of doing it. This might be a better way of doing it than that, but that's reasonable. We'll say constant mod val or remainder. Just call it r. So this is if r is 1 and if r is 2. And we're going to say if we'll do constant remainder, right? So if remainder is 1, if it's not 1 or 2, then we don't make any modifications, so we just return the total directly. So if the remainder is 1, and we say total equals the larger of either total minus mod 1, smallest value it's mod 1, so mod 1 0, or total minus mod 2 0 and mod 2 1. Two smaller values that are mod 2, or the one smaller value that's mod 1. And on the other side, if it's remainder 2, then it's going to be just swap these two, basically. And this is going to be mod 1 and mod 1, or mod 2. Okay, something along those lines. Let's give that a shot. It's maybe not the best solution, you know, I don't know, it's kind of double cannot be narrowed into initialize a list. That's kind of annoying. It's a little awkward, but okay. Not that big of a deal, you know, it's okay. It's okay, you know, it's all right. All right, let's see if this is correct. Yeah, okay, I think it's right. Let's just do some random things. So, you know, 1, 2, 3, 4. Let's do random stuff. And let's do just one number. There's always at least one number, right? And can always test those things, right? Just do a few tests before I go on to the next thing. Oh, okay. I missed that. I saw it, but I kind of just didn't register. All right, let's do like a few more. Just a few more random things. Those aren't commas. Oh, that's too much. I don't think I need to do more actually with this. This is probably fine. Let's do one more. I'm going to guess that it's okay. I'm going to go for it in a moment. So this, in terms of, well, let's see if it's correct. Let's start with that. Let's see if it's correct. Could be wrong. Oh, it's correct. Okay. All right. Beats most of the solutions. It's pretty good on memory. Let me try and resubmit it about 4 more times and talk about it while I do this. So yeah, this is It's not an insanely efficient approach. It's a relatively simple and straightforward approach. It's linear time in n, the number of elements. I'm not sure what else to say about it. It could probably be improved a few different ways. It's pretty simple, the idea. Hopefully I explained it well enough. That depending on what the modulo is at the end, if you want to bring it down to mod 3, you've just got to subtract a few numbers, and just removing the smallest of those numbers is going to give you the optimal that they're looking for. So thank you for watching. If you appreciate this video, give it a like and subscribe for more. I'm going to go ahead and start on another question. I'm going to go ahead and stop the stream here and start on a new question. So yeah, take care.